One more interesting problem involving tan and secant. Now, if you go by concept, it says that okay, if the power of secant is even, you substitute tan x as t. If it is odd, you substitute secant x as t. But here it is n. We don't know whether it is even or odd. So what we can do, we look that we only have one power of tan here, and we don't know how much power of secant is here. What we can do, we can substitute secant x as t here. So why I'm saying that, because you can generate the derivative here, okay, but if you take tan x as t, here you have to take out secant square x from this, but in the remaining portion again it will become a bit tricky. Okay, so the easier way is to generate secant x tan x. Now tan x was already there with dx. Now in order to generate secant x here, I took one secant from this secant power n. So I am left with secant power n minus 1. Fine. Now I can take secant x as t. I don't need to think further. Derivative of secant x is secant x tan x. And if I go back to the integral, this will become t power n minus 1. Secant x tan x is anyway dt. So integral of t power n minus 1 will be t power n minus 1 plus 1 divided by n minus 1 plus 1 plus a constant c. And what was t? It was secant x. So this will be secant power n x divided by n plus a constant c. A bit tricky problem because whether power is odd or even, that is not visible, but yes, we can somewhat manipulate this and generate secant x tan x, and once it is generated, this is some power of secant x which we can take as secant x as t. So t raised to some power there, which is easy to integrate. So we'll see some more problem like this in the playlist Integration 2023. Thanks again.